we're in Lancaster, New Hampshire, looking at a super energy efficient house with Al Rossetto, the builder and homeowner. But Al, you say that when you're building houses, your goal is safe, healthful houses for the people that live in it.
I think that we have to produce a building that is safe for people to live in, and that the indoor air quality equals outdoor air quality. And the only way that we can do that is to start thinking about indoor air quality at the footings. But what I need to do is I need to control all the variables that could possibly make the people that live in this building sick. So how I do that is thinking about, one, how do we fit the building to the site? This particular site has an enormous amount of ledge just under the surface, so we were unable to use a conventional foundation, hole in the ground type thing. It would have been below the water table, so the basement could have possibly been wet.
So grade, you were saying grade is about here, so we're only about 2 feet below grade.
Correct.
So this is a shallow frost-protected foundation that you've put together here.
Right, and what that means is that on the outside of the foundation, there's a 2-inch R10 blue board that extends out 4 feet completely around the building. It eliminates the need to go down into the bedrock to put the footings down below a safe frost level. And then we brought in sandy fill to grade the building away so we had good drainage away from the building. The downside of not digging a hole is that this building is relatively high off the ground. But it's above the water table, so climbing a couple more steps is a small price to pay rather than having water in my basement. I use a system called Thermodrains made by Certainty, and what it is a 2-inch wide by 8-inch tall rectangular pipe that has drainage slots in it. And what you do is you form this just like you would with standard 2x10 footing boards. You connect the two drains together through the footing so that anything on the outside or inside can get to either way. And the pipe is cast into the side of the footing.
So it's a footing form and a drain all in one, and it drains everything off to daylight.
Correct.
So you've got a former drain system, then you're using ICFs, which you and your crew can assemble pretty quickly.
These are adult Legos.
Adult Legos.
Honest. In fact, what I found is that the kids, not gray hairs, can put these things together because they've been trained in Legos. And honest, they do a wonderful job because they understand how it's supposed to go together. And it's so simple. All you got to do is follow the directions, look at the pictures.
And then the next system that's integrated is structural insulated panels.
Right. SIPs are very good for walls. They work perfectly for walls. Not so good for roofs, but they work there too. But one of the benefits of SIPs is they come in big pieces. Again, we only brought the foundation up to here. I could have gone to full height with it, but SIPs are cheaper than ICFs. So what I was able to do is put a 4-foot SIP sideways.
So this is all one continuous panel.
One piece, no air leaks. And when I put the wall up, I was done. There's no insulation. I don't have to worry about insulation. Yeah. I've got a little bit of caulking details to make sure it's good, but it's done. The other thing it gives you is it eliminates platform framing for the floor system. You want to have a continuous insulation plane from the footings to the roof. And my goal is to have no thermal breaks in the outside of the building. Indoor air quality is also a function of the shell performance. I want to put the people that live in this building in control of the indoor air quality. And the best way to do that, in my opinion, is to use an energy recovery ventilator.
Okay, and you've got one in here in the other room here.
What we do is we take the air from the bathrooms first, kitchen second. Those are the highest moisture areas in the building and the warmest.
Okay.
So this pipe comes down from the bathrooms in the house. Warm, moist air is going this way through the air exchanger. It delivers 80% of the heat and a certain percentage of the moisture into the incoming cold stream, which goes this way. And as the two pass, the heat and some of the moisture is transferred. The air, after it comes through the cold, fresh air, it goes here, and these pipes lead up to the bedroom closets. We put the air into the closet for 2 reasons. Even though this unit is approximately 80% efficient, if it's cold enough outside, it'll feel like a cool breeze. By putting it into the closets, the volume of the closet mitigates the temperature differential, and it keeps your clothes fresh. If you think about what you're doing and integrate it into the building design so that it's as easy as possible, I plumbed this in by myself in 2 days.
I see you also have a radon vent down below it.
There's no way to ascertain a new building will have radon or not. By using the former drain system, I can easily bring what's called a passive subslab ventilation system. This ties into the former drain below the slab, and then this vent pipe runs up and exits out the roof. And as you have a pipe inside a heated envelope, you get what's called a stack effect, and warm air rises in the pipe. And according to the engineers, what they tell me is that this system passively, there's no fan, nothing like that, it will depressurize the area under our feet by 3 to 5 pascals. So by depressurizing here a little bit, we've said to the gas molecules, well, here's an easy way to get out.
Here's your way out.
And they go up and they go out into the atmosphere, and the indoor air quality is that. Now, we have no way of knowing whether this building would have had a radon issue, but this pipe and the system is probably a $200 insurance policy that this building will not have a toxic gas in it. So we really need to look at the whole systems, integrate them together, and use them to create a healthy, safe house, because that's what we're doing. If we do anything else than that, we're doing a disservice to the planet and to our customers.